Hey everybody, welcome to that Whiteboard guy. Today we'll be talking about AWS. We'll be looking specifically at networking, VPCs, internet gateways, NAT gateways, subnets, firewalls. This session is prepped towards your exam readiness, and we will definitely be talking about some best practices as well that you will definitely have in the industry. So AWS networking, it is core to what you do in AWS and definitely core to the Solutions Architect Associate exam, your Cloud Practitioner exam as well. So stick with me. I will take you through some of these important concepts that I think is extremely important for your exams. So let's go and hopefully, and I'm actually sure that you're going to get some use out of this. So let's get started, shall we? I first want to go and draw out my AWS region. So I will go and say, cool, I will have an AWS region. And I want to draw it out like that, and then maybe just center that across the page. Now that is AWS, and that is the region, and that is typically where we will want to do most of our work. Now this also forms part of the AWS global infrastructure, and there's definitely questions that will form around the global infrastructure as well. So we've got a region, and in our regions, we have multiple availability zones. So there's my AWS regions. And what I'll do is I will first draw out my VPC. And in that VPC, I will have my availability zones. So here we go. I'm drawing out not like that. I actually would want to have this kind of color in there. Drawing out my AWS VPC. And I will label this as well and call that my VPC. My VPC will have, and it will stretch across those availability zones, and I will draw my availability zones next, right? So I've got my VPCs, and next thing that I want to do is to draw out my availability zones next. So we'll draw this out, and I will have not one, I typically will have, and this again is best practice, that you go and you set up multiple availability zones. So I'll go and I'll add another availability zone over there. And I will definitely label this as well. We'll label this AZ1. And I will label this AZ2. Now, we definitely know that there is the internet that we have to deal with as well. And we will draw out our internet as well. So over there on top, I will just draw out that internet over there. And yes, I shall label that too. And we will call this the internet. So we have traffic that needs to flow to the internet, and we have traffic that flows from the internet. What are the networking resources that I will need in here? Now, let's go. And if I've got a VPC, first thing that I will want to do with that VPC, I want to subdivide my network. My VPC, and this term you will need to remember for your exam, it is a VPC is your isolated networking environment. Now, my VPC will stretch across multiple availability zones. And what I will do now is I will go and subdivide my network, that VPC, and we will subdivide that using subnets. So I'll go and I'll draw out my subnets next. And I want to have multiple of those subnets as well. So we will go and have a subnet in this one VPC and in that availability zone. And what I will do is I will go take that, and best practice is that we create our infrastructure and we split that across multiple availability zones, and we will take it from there, and then we will split that across as well. So now I'm sitting with a highly available environment for me to put my AWS resources in. So let me go and label this as well. So we will label this as my public subnet. And what I will do is I will take that public subnet and I will go and copy that over, just do some renames just to make this a lot faster. So there is that one, there's that one, and then I will go and copy that. Not all of those. Go undo that, and I will take that one now. Yes, success. And I will copy this over. And then what I'll need to do is to just call this now private subnet. And I will show you what makes a subnet private and what makes a subnet public as well. So I'll call this private as well, but I'll make this private number 2. And I'll make this public subnet number 2. Right? And I will call that my public. Now I'm sitting with duplicated environments across availability zone 1 and availability zone 2. So I've got a public subnet 1, public subnet 2, private subnet 1, private subnet 2. And this ideally is when we start putting our resources in. So what do we want? Maybe I want to have an email server. That is no problem at all. So let's put together an email server or a web server. So let's go put in a web server. I think that is a better idea. So I'll have a web server in that public subnet number 1. And you guessed it, I will go and see if I can duplicate that across as well to the other one. And maybe one of the things that I want is app server. And maybe again, best practices says that I'll need to duplicate that as well. So now I'm sitting with multiple different servers. So let's call this my web server. And I will duplicate that web server into my other availability zone as well. So I will go and take that web server and I will go and copy that out. I'll take that and I will copy that over there. And what I also maybe would want to do is I also maybe would want to go and not have web servers, but maybe I would want to have an application server in a private subnet. Like, the idea is to keep and to restrict your services as much as what you can within AWS. So now I've got 2 web servers, 2 application servers, and you'll note that they are in different availability zones as well. So now I want to make sure that the web servers can speak to the internet. The first service that I'll need to put in play, especially around my VPC, would be a internet gateway. So we'll go and we will draw out an internet gateway, and we'll add that internet gateway and attach it to our VPCs. So your internet gateway goes and it attaches to your VPC, and let's label that as well. We've got it IGW, and that lives across your VPCs. So both availability zones are able to access that internet gateway to send traffic out towards the internet. So the effect that we would want is for traffic from those web services to be able to go via that internet gateway and send it out. Now, there's still some work that we need to do to make all of this happen and to make sure that traffic goes where they need to go. Now, in my private subnet, there's definitely a resource that I would want rather in a private subnet than a public subnet. So that is the next service that we maybe would want to go out and draw. So maybe in a private subnet, I would want an internet, not an internet, but maybe a database, right? And I will draw up another database, and you guessed it, in availability zone 2 as well. And again, I will label this and call this my DB, but I'll call this my DB PRI for my primary database. And the second database that I would want to draw up, I'll make this my DB, but I'll make this my secondary database, and I'll label that out as my secondary database. Now I'm sitting with 2 databases as well, a primary database and a secondary database. The idea is that as traffic goes into my primary database, I would want to go and replicate that across to my secondary database as more data is being written to it. So I've got my region. In my region, I will have multiple availability zones. I create my VPC, my isolated networking environment, and that VPC will spread across the availability zones that I choose. And then I subdivide that network into public subnets and into private subnets as well. So I've got multiple resources running in there. So now I'm sitting with all of this. What is the means for all of these traffic to be able to go and transact with? So how does that web server know that it needs to send traffic to the internet gateway? This is where we start talking about some additional services. And I want to start off by talking about route tables. So I will go and just write out over here and call that my route tables. and you will have different types of root tables. Now, in my public subnet, what makes a subnet public and what makes a subnet private? So now let's go and draw up a subnet for our public, or a root table for our public subnet. So we'll go and we'll draw that out, and we will call this my public subnet root table. So now I've got a public subnet root table, and I would want to take that public subnet root table, and I need to go and add roots in there. The roots that I will add in there typically for public subnet will say something like, if this VPC IP range is 10.0.0.0/16, that first public subnet 1, I will make 10.0. Let's call that .2.0/16, and for it to send traffic locally, I'll say you will keep that local. That is a root table entry, very similar to that. I'm just doing some short coding in here. And then what makes a public subnet, or what makes a subnet public, is if I add the following root. So now I'm going to go and add another root in there. That root for the internet, we say 0.0.0.0/0. This is any traffic. We say you will send it to the internet gateway. So now I'm sitting with two root table entries, one for local traffic and one for the internet gateway. The moment I have that in play, what you will find is that now I have, if I attach this public root table, if I attach it to that subnet, it now becomes a public subnet just by that entry that says 0.0.0/0. This entry makes it a public subnet 0.0/0. Brilliant. Now, what happens now is that this EC2 instance is now able to go and send traffic. It says its root table entry. It says, hey, where do I send traffic? It says, oh, traffic for the internet goes to the internet gateway. So it will go and say, sure, let me go and now send that traffic over to the internet gateway. Internet gateway sends that out to where it needs to go, to the public internet. That web server is now able to function and send traffic over to where it needs to. Now, this web server still needs to send, maybe after the traffic's coming in on port 80 or port 443, maybe needs to send it now to the app server and then to do some updating to a database. Now, another best practice is to decouple your environment. And one of the best ways to decouple your environment is by putting into play a load balancer. So now we can have a load balancer. We'll call that an elastic load balancer, and there are different types. Two most common types that you'll find in this type of architecture would be a network load balancer and an application load balancer. So now what happens is that traffic is able to go and send via this web server. It is now able to go and send that traffic and send that to that elastic load balancer. Elastic load balancer is now able to go and say, sure, let me send the traffic either to one of these two instances as well. It is able to do that. It is able to go and it checks for the health of those app servers. If one of them is in an unhealthy state, it will say, oops, I can't send traffic to it, and it won't. So it's sending it to a healthy app server, and that app server could now do a specific write to a database, to the primary database. The primary database by itself, what it will do is it will do maybe some replication across to make sure that your traffic, your secondary database is always updated. Now, there are definitely AWS services that can do this for you as well with very little work, but I just want to, for completeness, speak about the fact that we want replication in here as well. And let me label that and call that replication. So now I've got replication. I've got from my primary database to a secondary database. I'm only writing to my primary database. My primary database is updating my secondary database. So my web server is able to speak to the internet by the Internet Gateway, and you find how to do that via the route table entries that it has in there. This speaks to a lot, but what it doesn't speak to is what happens to that private subnet. Now I'm going to go on the other side. I will go and let's go label this as well. Maybe label it over there and call this also route tables. And then I will have this route table that is now attached to a private subnet. Now in a private subnet, I will go and say, hey, route table, no, let me create one, and I will create a new route table entry for it, and then call that private subnet route table. I'll call that. And in that private subnet, only thing that it will have is 10.0.0.0/0 via the local. So it will send all local traffic. It knows what to do with it. It will send it and keep it locally. But what happens if this app server needs to maybe also speak to another servers on the internet? Because it's in a private subnet, there is no route to the internet. So what we do is we add a device, and then we add another route table entry into it. So the device that we'll add, and I will go and draw this out. Now this is fairly important. The device that I draw out needs to be in a public subnet. So there's a device that I draw out, and it needs to be highly available as well. So when you have it in the one subnet, you also need to make sure that you have it in the other public subnet as well. And now let's label this, and we will call this by its name, which is a NAT gateway. So now I've got a NAT gateway, and the NAT gateway allows me to have devices in a private subnet that it will use to send on its behalf traffic to the internet by masking the address of that device in that private subnet. So let's go and let's just label it across as well. So we'll quickly go and label this, and we'll just copy that label across to the other side as well. Now I'm going to use the app server in private subnet number 2. So it now needs to send traffic to the internet. So now we go and we add a route table entry in our private subnet, and that route table entry will say 0.0.0.0/0. This is internet traffic. I want you to send it to that NAT gateway. You see where we're going with this. So now I have this route table entry in my private subnet that says, hey, you may not know what to do with it, but what I want you to do is to just send it to that NAT gateway. So this app server says, great, let me go see what I need to do with that kind of traffic. Hey, where do I send it? It looks at its route table entry and it says, oh, it needs to go to the NAT gateway. So what it does is it will now go and send the traffic to that NAT gateway. And then from that NAT gateway, send the traffic to that NAT gateway. And there it sends it. Now I've got that traffic to the NAT gateway. NAT gateway says, hey, there is a public subnet route table entry that has been attached to me as well. And that same in, we can also add on that one as well. So we've got that on there too. So it is living on the other one as well. So now it sees, where do I send traffic? So it will go and it will say, I need to send traffic to the internet. Where do I send it? Looks at its own route table. It says, hey, I've got traffic that needs to go to 0.0.0/0. Where do I send it? Internet gateway. So it now goes and says, cool, I've got my route. I know where to send it to. And it also sends it to the IGW, and the IGW sends that outwards as well. So devices in a private subnet is able to still send traffic to the internet via a NAT gateway. Still need to talk about security as well. So on this, and in AWS, if there's traffic coming into your VPC that wants to come into your Subnets. There are two firewalls that we can start talking about. First firewall is on my subnet level. So I'm going to just make another label and call this virtual firewall. A virtual firewall that will protect my subnet level. And I'll draw this out as well. And we will call this my subnet level. And there on my subnet level, I have a device virtual firewall, and that virtual firewall device is a network access control list. The network access control list is a virtual firewall that will protect my subnet devices. And that lives on the subnet level, and it protects that subnet. There is another virtual firewall as well, and I will go and label that as well, and maybe we'll put it over there. So there's another virtual firewall that protects my resources as well. And what protects my resource level is, and I will draw that out too, and resource level. And on a resource level, the device that will protect me on that resource level is called a security group. There's my security group, and it will go and it will protect my resources on that level. So now I've got multiple devices or virtual firewalls that can protect my environment. The one will protect it on a subnet level, which is my network access control list, and the other one will protect me on my web server level, and that will be my security group. So we've got security groups that will protect my web server, my NAT gateways, my load balancers, so the resource level. And then on my subnet level, we've got my network access controllers that will protect devices in there. So I've got that running in there. And all of this is how I will have some protection over my devices. And this also is a best practice from AWS that you'll take and use your resources across multiple availability zones. You can see I've got two web servers, I've got two app servers, I've got two databases in different availability zones. Should there be a failure in one availability zone, the other one or the other availability zone is still able to go, and I'll have some of my devices still accessing and still providing service to my customers. So this, in a nutshell, speaks to some of the concepts that you need to remember for your exams. I will have a shorter video that speaks to the differences between network access controllers and security groups, which is extremely important for those doing the exams. And hopefully this was of use to you. And again, it's been an absolute pleasure. I'll see you on the next one. Have a great day, everybody. I will see you soon in one of these other videos. These videos are live. This is why there's always some changes and some tweaks that I make live, because I do this live. I do them in one-shot recording. And again, if you like it, please subscribe and please tell others as well about these videos, because I do think that they have a great value in your life in AWS and in getting certified as well. Good luck. Bye.